When you go to the website quantemoldb.com, it will bring you to this page. You need to sign up for a free account. Click on this button. It will bring you to a form, and then you will receive an email confirmation, and from then on you will be able to log in. What you can do on this website is you can search for the data or for reactions, and you can also look into chemistries we pre-assembled, but today in this tutorial I would like to show you how to assemble your own chemistry. So let's go to Dynamic Chemistry section. Yeah, so it brings us to this form, which will guide us through several steps in assembling our own set. I would like to assemble argon and oxygen chemistry, so I select my feed gases here and I click on button update. After the update, it brings me up the species which I can select, and the species are separated in the types of species, so you make your choices mindfully. So I will make my choices rather quickly. After selecting my feedstock gases, it brings me up all associated species which it could find in a database. So now I need to make my choices of what I would like to include in my chemistry. Here, I will be building up a discharge for low pressure plasma, so I don't expect ozone to be formed. Then I click on update again. Now it selected all the reactions related to the species I included. Again, I will be making my choices now. And our recommendation is actually trying to start with relatively simple set. So don't select everything, but select the minimum and then add on complexity by adding other reactions. And now I can click on update. That's an important step. So now what we can do is we have three options, or we can download it. If you have gold membership, you can download it in any convenient format, such as, and we work together with different companies, like, for example, people who use CFDAs or COMSOL or Visgo, so we can download it. And additionally, you can save a chemistry set and then retrieve it for modeling in the tools available online. Specifically, I will go to Boltzmann solver now. So we can, for example, add some other PCs. So let's add them here. Then we should okay, now let's calculate the rate. Okay, now we can see the results of this run. So let's look at the electron temperature. The thing to watch out for, that it should increase monotonically and will be like a smooth function of the reduced electric field. So you don't expect any zigzags here. And to ensure validity, also look at the EDFs. So this interesting structure is related to resonances in the vibrational state of oxygen, but in general, these are smooth graphs, and that's what you should expect. If you have some kind of gaps or seeing low energy electrons, sudden peaks, some discontinuity, that suggests that maybe something is wrong. And if you cannot identify what it is, please contact us. Yeah, and here is our rate. Also, all of these graphs may have the logarithmic axis if you wanted to. Okay, so now we can use the same set, so you don't need to make any changes. Then just go to this section called global model, and here, okay, so you can see that there are some Macroscopic parameters you can change. Let's say I want to change, for example, make it current ratio for argon oxygen, and I can also set some specific peaking coefficients. So let's go here, and I can add I can also add pulsing to this model. So for example, I can make 4 pulses and make it 1 kilohertz and hit run. So let's look at results now. So here we have the actual values for densities. Here they are represented as chart, so you can visually compare them. Here our very nice temporal evolution of electron density responding to pulsing. We can also zoom in on graphs. We'll look at them with higher resolution. Here you see the button, and the same button we had on the Boltzmann solver, where you can restore as set if you wanted to work with it again. In order to evaluate more or less quickly if your model results are reasonable, so you need to ensure that, first of all, electron density shouldn't be 0, or electron temperature should not be higher than 5 eV, because usually these are two symptoms of the fact that discharge cannot be sustained with the given parameter combination. This is an online application. We also have an offline application which will do a little bit more of checking the data to ensure that you have a right chemistry set, such as will tell you if you have missing ion-ion recombination reactions or some terminal species. But try to work with this one, and if you have any questions, also feel free to email us. And now let's go back to the presentation slides. Thank you very much for listening to this talk. Really happy to have had a chance to present our work here. If you have any questions, feel free to email us on support@quantemol.com. Also follow us on our social channels like Twitter or LinkedIn.